Okay.
All right, go.
All right. Well, today in MAC 248, we are having the Tuesday class. We're not going to have a Thursday class because of the show or the Ames meeting taking place in the shop. Today I introduced chapter 14. It's also called lean supply chains. But the real reason for this is that lean supply came about because just in time cut things too close to the bone. Just in time is, in a lot of industries, very vulnerable to disruptions. If an earthquake or a tsunami or a strike or a wildfire in the wrong place happens, disruption to all the worldwide supply chains can take place. And I accentuated in the beginning of the chapter how if you lose your customers one time, it's very difficult to get them back again. So having a little extra padding is definitely a healthier option. But also, the lean production thing forced theoretical concepts to be adapted to reality. So, you know, the goal was written back in the 80s, and it shows a physicist taking up organizational problems at a manufacturing company and applying academic theories to it to improve the place. So I just find it fascinating that we can point to several places where academic ideas and academic ways of working things out sometimes do have direct practical application. They take a little bit more work, but it has done very well with lean manufacturing. So we're introducing lean production. Integrated activities designed to achieve high volume, high quality production with minimal inventories of work in process, raw materials, and finished goods. You don't want warehouses full of finished goods. That's risky. You don't want piles of work in process inventory. That's not an asset, it's a liability. So, what is waste in the lean production world? Waste has many definitions, but the one that is the most important is waste is anything that does not add value from the customer's perspective. I use the example of the QA department that we had in the 80s and 90s. We'd have 4 or 5 guys, all kinds of measuring equipment. We'd check a whole bunches of parts, maybe every single part that came off the machine. You know, the customer does not want to pay for QA. He expects a good part in his hand. Hiring and buying all that machinery, if it was unnecessary, could be seen as waste because it does not add value to the product. You cannot prove that it adds value directly. So consequently, QA departments have been shrinking ever since then, and more responsibility devolves for quality to you, the machinists, there out at the machine. What customer value represents is anything they're willing to pay for. And if you have a perception of high quality, they're willing to pay more for your product than anybody else's. So, I talked about the Toyota production system. I highly recommend looking up on YouTube the Toyota production system, Toyota Kanban, Toyota Lean. And there's a lot of really great videos and depictions of academics applying and using that Toyota example in their high-level college courses for management, for instance. I went over how the Japanese were different people than us. They have a much different culture, much more uniform culture, and they foster cooperation among their companies and homogeneity among their people. When their babies and kids are small, they teach them that the nail that sticks up will be hammered down. Consequently, there are bad and good things for that. They are not the most inventive people in the world. They have excellent quality and they have excellent continuous improvement processes, which is why Toyota kicked everybody's rear end in the 80s and 90s. So I talked about lean suppliers, the value stream, lean manufacturing, lean warehousing, lean logistics, and even lean customers. What is a lean customer? A lean customer is one that knows exactly what they want. The bane of a lot of shops is the inventor that comes in that has a great idea but doesn't know exactly what he wants. He has not thought it all the way through. He has not even designed it all the way through. He is not a lean customer. Lean customers have a great understanding of their needs and specify meaningful, exact requirements. I talked about lean layouts like they have at the GE plant here. They invested $115 million and put a new wing of the plant, and the machines are grouped by their place in the production line, kind of. You group technology manufacturing types, not by specialized equipment. I gave the example at Westinghouse, we had a row of huge horizontal milling machines. Well, the parts would have to go back and forth in the plant like this. Whereas if we would have grouped this horizontal next to this vertical, next to this grinding machine or whatever, you smooth the flow through the plant like that. That's a lean layout. I talked about just-in-time production on page 248. I talked about lean scheduling, which means you have a level schedule and you have uniform plant loading, just like in the goal. In theory of constraints, you're trying to balance the flow to meet the demand. Uniform plant loading, it says in this book, is smoothing the production flow to dampen schedule variation. We talked about how we had to withhold production on non-bottleneck machines so that it wouldn't create log jams. The last thing we talked about was Kanban. And I also talked about, before I do that, I talked about the vertically integrated company. It used to be raw materials up here at the top, coal, iron ore, processed into the usable form, made into parts, assembled into a machine, sold as a machine at the end. That's the way it used to be done at John Deere, Ford, all kinds of places, and remarkable things were achieved this way. But over time, it became a much better idea to have a horizontal organization and everybody see themselves in the manufacturing thing as one part of the supply chain. So this horizontal thing is like a chain. Kanban is a signaling device, and that's what the word means. Kanban was best described by a signaling device used to control production. They'll have a square, and people will drop goods in it as they're made. And as long as the square has a part in it, you don't make anything. As soon as the square is empty, then you go ahead and make it. It's a just-in-time application, but it also goes great lengths to smooth flow through the plant. I showed the exhibit 14.3 on page 248, and I'm going to include something on that. Inventory hides problems like rocks under the water. How do you go about getting, if there's so many rocks under there, how are you going to fix the flow through your plant? Well, you start by lowering inventory levels. And the first problems that are going to be the worst problems will come to the surface, and now you have less work to remove the rocks, and you have a more organized way to go about continuously improving your processes. The act of lowering the inventory will show the worst problems first. There's risk involved in that, but you got to start somewhere. So the last thing was finish chapter 14. Read it. Read it all the way through. If you know about this kind of stuff in the places that you go from here, you may be able to help an outfit stay in business. At the very least, if an outfit is already doing this lean production stuff, you're going to know the lingo, you're going to know the terminology, you're going to be able to contribute. So read the chapter well. Study the terms on page 259 for the first two learning objectives, then do questions 1 through 3 on page 65, and then 1 through 4 at the bottom of the page on 265 as your makeup work for missing this Thursday. It will be due and to be handed in at the start of class next Monday, the 28th. Thank you and have a good little break.